Hello guys, welcome to the else channel. So now in this video I'll be solving some past questions in regards to some Navy Marine Engineer officer past questions. So the examination is administered by the Scottish authority on behalf of the Maritime agency. So these are past questions from 2015 to 2019. So I'll start from 2015, then go to 2016 and continuously. So this is for the engineering knowledge motto. This is for batch March 2015. It contains 9 questions. Then the next one is for July 2015, the next batch, which is engineering knowledge motto. That is for July 2015. Then the next one will be solving and explaining, is October 2015. Yeah, that is under the engineering knowledge motto. So all these questions are regards to motto. So now the next question we'll be looking at is the engineering knowledge motto for December 2015. So for each year there is 4 batches: the March, the July, the October and the December. And we'll also be looking at 2016, yeah, starting from March. Then we'll also look at the July, and also we'll be looking at the October, and finally the December. So we have a lot of questions, and continuously until we reach that is 2019 December. That's where the question ends. So we'll see how we'll be able to solve it. So now let's get back to business, and we'll start with the 2015 engineering knowledge motto. So this is the question. Attempt 6 questions in all. So they usually ask 9 questions, and you are expected to answer 6 questions only. The marks are attached by the right hand side, and each question may have A, B, sometimes A, B, C. Sometimes there might not be an A, B, C. There might just be a question in which you explain and give them a detailed explanation. So now let's get to work. So now this is for the engineering knowledge motto for March 2015. So the question is question 1. Describe with the aid of a sketch an open loop system for reducing SOx emission from engine exhaust gas. SO means sulfuric oxide. Explaining the system operates while the vessel is in open water. Then the big question is describe with the aid of a sketch a closed loop scrubber system for removing sulfuric oxide from engine exhaust gas. Explain the operation of this unit and stating when it would be used. So the answer is, for question A, an open loop system for reducing SOx emission from engine exhaust gas can be achieved through the use of what? Desulfurization. So desulfurization is the process of what? Removing what? Sulfur oxide from an engine exhaust. So now here is a sketch describing the principle. So now we have the engine exhaust. So now this engine exhaust exude and produce sulfuric oxide, which is then passed into the desulfurization unit. So now this desulfurization unit is where the SOx gas will be removed. This SOx can be SO2, SO3 or SO4 as the case may be, and therefore the exhaust gas is what? Removed. Therefore this exhaust gas you're seeing here does not have SOx. So now the principle by which SOx is removed from the engine is known as desulfurization. More explanation. So now in an open loop system, The sulfurization unit is directly connected to the engine exhaust gas outlet. So now this engine exhaust has an outlet. The unit typically consists of a series of chemical processes or filters that help remove sulfur compounds from the exhaust gas. So now this desulfurization has a lot of filters which can be used to remove these sulfur compounds. This can include techniques such as scrubbing, adsorption, or chemical reaction to convert sulfur compound into less harmful substance. So now this SOx gas that we have been talking about, it is a global gas or global warming gas which causes global warming. The system operates continuously, next slide, while the vessel is in open waters, treating the exhaust gas as it is released from the engine. So now the second question is, describe with the aid of a sketch a closed loop scrubber system for removing SOx from engine exhaust gas, explaining the operation of this unit and stating when it will be used. So now this is the solution. A closed loop scrubber system for removing SOx from engine exhaust gas operates as follows. So we have the engine exhaust, the scrubber system, the exhaust gas. What is only added here is the wash water tank. So now in a closed loop system, the scrubber unit is connected to both the engine exhaust gas outlet and a wash water tank. The scrubber system sprays water or a chemical solution such as sodium hydroxide. So now this scrubber system, in the other case we are looking at desulfurization unit, but in this case we are not looking at desulfurization unit, we are looking at the scrubber system. So now this scrubber system sprays water or a chemical solution such as sodium hydroxide. So now this sodium hydroxide is a neutral compound into the exhaust gas, which reacts with the sulfur compounds to form non-harmful substance. So now in this scrubber system we have sodium hydroxide. So when sodium hydroxide is now sprayed with these sulfur compounds, they react chemically and produce non-harmful substances. The wash water now containing the absorbed sulfur compound is collected in the wash water tank. So after spraying this scrubber system, that is the sulfur compound with sodium hydroxide, there will still be some residue which will be stored in this wash water tank. So now the system is used when the vessel is in an emission control area, ECA. So there must be proper ventilation, where restricted regulations for sulfur emissions are in place. The wash water containing the absorbed sulfur compound is retained on board the vessel and disposed of according to environmental regulations. So now this wash water tank, it must be regulated and decomposed following the environmental regulations. It should not just be sprayed on people's farmland, but it should be decomposed properly. Neither should it be sprayed or poured into pond or riverine area, because these compounds are very deadly. They can lead to death of live animals. This closed loop system ensures that the sulfur compounds are effectively removed from the exhaust gas before being released into the environment. So now, next question. Question 2A. The question is, define the term torsional vibration with respect to an engine crankshaft, stating the effect that high levels can have on an engine crankshaft. B. Explain how engine deterioration influences the risk of torsional vibration, stating what can be done to minimize that risk. C. Explain two possible reasons for the activation of a torsional vibration alarm after an engine has been started if there had been no previous history of such an alarm, and if no maintenance had been undertaken on the engine while it was stopped. So the answer, question 2A, define the term torsional vibration with respect to an engine crankshaft. So now, torsional vibration refers to the twisting motion and oscillation that can occur in an engine crankshaft. So now, the ability for an engine to undergo twisting and oscillation, that means it is operating on torsional vibration. It is caused by an irregular force acting on the crankshaft during the combustion process and the transmission of power to the engine rotating component. These forces result in torsional stresses and vibration in the crankshaft. So I can liken it and explain it and break it down to you that this torsional vibration is just the movement of the car engine pistons. So now that ability for the piston to go up and down is known as twisting motion or an oscillation. This is also known as torsional vibration. These forces result in torsional stresses and vibration in the crankshaft. High levels of torsional vibration can have detrimental effects on an engine crankshaft. So negative impact of high torsional vibration can lead to 1. Fatigue failure. So that the repeated twisting motion caused by torsional vibration can lead to fatigue failure of the crankshaft. What do we mean by fatigue failure? Means that the metal casing of this crankshaft can become weakened over time, which may lead to breakage and breakage. So now the next one is misalignment. Torsional vibration can cause misalignment between the crankshaft and the engine component. So when there is a lot of torsional stresses, that is the force over the area, they might lead to misalignment. The next question is, engine deterioration increases the risk of torsional vibration due to several factors. So the question is, explain how engine deterioration influences the risk of torsional vibration and state what can be done to minimize that risk. So these are the factors: wear and misalignment. So in regards to wear and misalignment, regular maintenance and inspection are essential to address wear and misalignment. The next one is lubrication issues. So now in this case, in order to reduce lubrication issues, regular oil analysis and maintenance of proper lubrication level can help minimize the risks. To minimize the risks of torsional vibration in engines, the following actions can be taken: 1. Regular maintenance. 2. Balancing. What do we mean by balancing? Perform balancing of rotating engine components, including the crankshaft, piston, and the connecting rods. So the crankshaft and the piston and the connecting rods must be aligned and balanced well in order to ensure that the engine works perfectly well. Vibration dampers. So one can be able to install vibration dampers to ensure that this risk is reduced. Monitoring and analysis, periodic monitoring, collecting data can help to reduce this effect. So the C question is, explain 2 possible reasons for the activation of a torsional vibration alarm after an engine has started. So 2 possible reasons for the activation of a torsional vibration alarm after an engine has been started with no previous history of such an alarm and no maintenance undertaken on the engine while stopped could be: 1. Change in load condition. So one can be able to change in load condition. If there is a sudden change in the load on the engine after it has been started, such as a rapid increase or decrease in power demand, it can result in unbalanced forces acting on the crankshaft. So when there's a change in load, so if the load isn't just moving and you suddenly notice that it isn't just went below that pitch, very low slight noise, you should be able to know that there's a change in load condition. The next one is component failure. A failure of an engine component such as a bearing, crankshaft or coupling can result in uncontrolled and excessive torsional vibration. So now component failure is one example. So these are the two possible reasons for the activation of a torsional vibration alarm. So now these two conditions, which is change in load condition. So when you notice that there is a change in load, that means you can be able to activate what torsional alarm system. And secondly, when there is a component failure, right, you can activate this torsional vibration alarm system. Question 3. As a chief engineer official, write instructions for the action to be taken in the event of a high temperature scavenge alarm being activated during a period of UMS operation, stating the reasons for each action. UMS means unattended machinery space. So now the question they're asking you as a chief engineer officer is write instructions for the action to be taken in the event of a high temperature scavenge alarm being activated during a period of unattended machinery space operation. So now, as a chief engineer officer, here are the instructions for the actions to be taken in the event of a high temperature scavenge alarm being activated during a period of UMS operation, along with the reasons for each action. So first of all, you must acknowledge that there is an alarm. Immediately acknowledge the high temperature scavenge alarm to ensure awareness of the situation. It is crucial to be alerted to the alarm and initiate appropriate actions promptly. First of all, you must be attentive. Your ear should be able to identify that there is an alarm sound. 2. Your eyes. There must be visual inspection. If possible, remotely access the camera feed or monitoring system to visually inspect the scavenge space and associated components for any visible signs. So now the first step, you should be able to use your ear to know that there is an alarm, there is a noise making noise. Then the second step, you should be able to use your eye to visually inspect the issue. Visual inspection, even remotely, can provide initial information about the severity of the situation. 3. Check scavenge air filters. So you should be able to check the filters. Verify the condition and cleanness of the scavenge air filters. So after hearing the sound of the alarm, checking the visual monitoring, next you should be able to check the filters. Certain times dirt can be able to clog around the filters, which may lead to increase in temperature, might trigger the alarm. So now the next step, you should be evaluate operational parameters. Review the operational parameters such as the RPM, the fuel and consumption based on available data. So there's certain times abnormal increase in the operational parameters can lead to such high load. So you should be able to evaluate the operational parameters. If it's supposed to be 50 RPM and you're seeing 40 RPM, there's tendency that might trigger the alarm system. So then the next step, you should be able to contact the duty engineer on call, right? There is always a duty engineer on work, so you should be able to contact him. Inform the duty engineer or relevant personnel about the high temperature scavenge alarm activation. Involving the duty engineer on call personnel ensures that experienced individuals are aware of the situation, which can be able to trigger a proper solution of the problem. Next, you can log the event, record the alarm activation. Next, you can do continuous monitoring. Next, you can go to troubleshooting and diagnostics. Next, you can also do remote adjustment or shutdown. So there's, if possible, and with the guidance of the duty engineer or on-call personnel, remotely adjust the engine, right? So adjusting these operational parameters can help to shut down the engine and prevent further catastrophic failures. Next is to do follow up and reporting. Provide the detailed report for the engineering superintendent. Document the incidents, actions, findings, recommendations for any necessary follow up actions. The reason is because reporting the incident and sharing the findings with the engineering superintendent can help to solve this issue. Question 4. Explain why charged air coolers are fitted to turbocharged diesel engines, stating the possible effect on engine operation and performance if they are not maintained in good condition. So now, the next question: as chief engineer, write instructions for the routine in-service checking of charged air cooler performance and cleanliness, together with the checking of condensate draining. C. State with reasons the possible consequences if condensate is not drained from the charged air coolers. So now the first question is, they want us to explain why charged air coolers are fitted to turbocharged diesel engines, and we should be able to state the possible effect on engine operation and performance if they are not maintained in good condition. So now the first question is, charged air coolers, also known as intercoolers. So now charged air coolers are also known as intercoolers. They are fitted to turbocharged diesel engines for several reasons. So now these are the reasons why intercoolers, also known as charged air coolers, are fitted to turbocharged diesel engines. Number 1, it helps in cooling the intake air. Certain times the heat exuded by these diesel engines are so hot, so you need these these air coolers, also known as intercoolers, to help cool the air intake. The next one is to prevent detonation. So now lowering the temperature of the compressed intake air helps to reduce the likelihood of explosion, right? So that's why we use the intercoolers or air coolers. Next, increasing power input. So when we use air coolers, there's increase in power output. Increase in power output. So if the power is supposed to be 50 megawatts, using an intercoolers, the power will be like 60 megawatts. So now enhancing engine durability. The use of intercoolers or air coolers helps to increase the engine durability, the strength. If charged air coolers are not maintained in good condition, that is the second part of the question, several effects on engine operations and performance can occur. There will be reduced engine efficiency. Instead of hitting the target of 90% efficiency to 100% efficiency, the efficiency will be reduced to around 60% or 50%, which means that there is high loss. Next, increased fuel consumption. So when if charged coolers are not maintained or intercoolers are not maintained, there will be reduce the energy efficiency. There will be increase in fuel consumption. Instead of you using maybe 100 liters of fuel or petrol, you'll be therefore using maybe 300 liters of fuel. Increase in fuel consumption, leading to high costs. Higher exhaust gas temperature. There will be higher gas temperature. There will also be elevated cylinder temperature. So now this elevated cylinder temperature are temperature in the combustion chamber. So the temperature will be very high, ranging from 60 and if possible ranging from 40 to 60 degrees Celsius, which is very, very hot. So now the next question is, as chief engineer, as chief engineer, write instruction for the routine in service checking of a charged air cooler. So in this question, you want you to write like a detailed step in service as a chief engineer. So here are the instructions for routine in service checking of a charged air cooler performance and cleanliness, along with condensate draining. So the first thing, as a chief engineer, you must do visual inspection. So you should be able to regularly inspect the charged air cooler for any signs of damage, such as leaks, corrosion, rusting, or bent vanes. Ensure that there is no obstruction to airflow, such as debris or oil build up. So first of all, the first thing you must do what visual inspection. So the second step is towards cleanliness. Verify that the charged air cooler is clean and free from dirt. After doing the visual inspection, ensure that the air vents and the coolers are free from dirt and dust. The next thing you should do pressure drop measurement. Measure the pressure drop across the charged air cooler to assess its performance. So higher pressure drops, then the recommended limit may indicate blockage in the cooler. So when there's high pressure, that means there might be some blockage in the coolers. Therefore, you can be able to take appropriate action. Next, condensate draining. Check and drain condensate from the charged air cooler according to the manufacturer recommendation. So most of these machines have manufacturer recommendation, so you should be able to read through and be able to drain the condensate, right? Next, you should be able to take record keeping. Maintain a log. You should be able to have a log where you record the inspection. If it's weekly, be able to write, okay, week 1 I took these precautions, these steps. Week 2, this is this. Week 3, or if it's monthly, first month, second month, or if it's quarterly, ensure to take record keeping. C. What are the possible consequences if condensate is not drained from the charged air cooler? So now this condensate are those physical and those structures that you can feel with your hand. So it might lead to corrosion. So accumulated condensate contains water and impurities, right? They are kind of solid. They are not soluble. That can promote corrosion with the charged air. So if the condensate is not drained, there will be corrosion. 2, there might be reduced cooling capacity. 3, there might be increased fouling. So now this increased fouling might be the increase of black smoke. Question 5. As a chief engineer, write a report to the engineering superintendent regarding the failure of a high pressure fuel pump unit on an electronically controlled engine. The report must explain the nature of the failure, how the failure was detected, and immediate action taken. The report must also explain the actions taken to replace the pump and the steps taken to minimize the risk of future similar fuel pump failure. So what they're asking as a chief engineer, they want you to write a report to your boss, who is a superintendent, about a high failure pressure fuel pump unit on an electronically controlled engine. So what should be contained in the report is that 1, you should be able to explain for him the nature. 2, you should be able to explain the failure that was detected. 3, you should be able to give possible immediate action steps. And finally, the report must also explain the actions taken to replace and steps taken to minimize the risks of future failure pump issues. So first of all, you write your name. If your name is Mr. Labaja, if your chief engineer's officer name is Mr. Labaja, you write Mr. Labaja, chief engineer officer, the ship name, and the date. So you write the subject, report on failure of high pressure fuel pump unit on electronical controlled engine. You should be able to write a captivating subject that when he reads it, when Mr. Labaja reads it, you know that okay, this is what he's saying. So now you now write dear this, right? So now you now write dear this. Then you can continue. I am writing to provide you with a detailed report regarding the failure of the high pressure fuel pump unit on one of our electronically controlled engine. The incident is detection, immediate action, replacement, and what preventive measures are summarized below. So you write the nature of the failure. On this day, okay, on March 14th 2023, we experienced a sudden failure of high pressure fuel pump unit on model, then write the number, maybe VIX11, installed on the engine name and the what serial number. So you must give specification because you're reporting to your what superintendent, that is your boss. The failure attributed to a mechanical loss or issue within the what pump, resulting in a complete loss of fuel pressure delivery to the engine's injector. This caused an immediate engine shutdown and a disruption to the vessel's operation. So now, after giving him the nature, the next thing is to what? Give him the detection of the what? Failure. The failure of the high pressure fuel pump unit was detected through the following means. So, number one, engine performance monitoring system. The system raised an alarm indicating a loss of fuel pressure, which triggered an engine was shut down. The alarm was promptly acknowledged and the engine was secured. 2. Visual inspection. Upon visual inspection of the engine component, we identify signs of fuel leakage and abnormal noise emanating from the high pressure fuel pump unit. This observation further confirmed the pump's failure. So this is the detection of the failure. First detected by engine performance monitoring system, that is through the alarm system, and second, you're using visual inspection. Now the next step is to give him the immediate actions taken. Upon detecting the high pressure fuel pump unit failure, the following immediate actions were taken. So these are 3 actions that should be taken. Emergency shutdown. The engine was promptly shut down to prevent any further damage or hazard caused by the lack of fuel supply. 2. Isolation and tagging. The failed high pressure fuel pump unit was isolated and tagged out of service to prevent its inadvertent use and to facilitate further examination. 3. Investigation and root cause analysis. Our engineering team initiated an investigation to determine the root cause of the high pressure fuel pump unit. This involved a detailed examination of the pump unit, including disassembly and inspection of its components. So emergency shutdown, isolation and tagging, and investigation of what root cause. Next is the replacement of the pump. Based on the findings from the root cause analysis, it was determined that the high pressure fuel pump unit needed to be replaced, and the following steps were taken, which are procurement. A replacement high pressure fuel pump unit of model this was promptly secured from our designated supply to minimize downtime. 2. Installation. The new pump unit was installed following the manufacturer's recommendations, procedures, and specifications. All associated components such as gaskets and seals were also replaced during the installation. Lastly, testing and commissioning. After the replacement, the engine underwent thorough testing and commissioning to ensure the proper functioning and performance of the new high pressure fuel pump unit. So now we are going to give the preventive measures. To minimize the risk of future similar fuel pump failures, the following preventive measures have been implemented. 1. Enhanced maintenance schedule. The high pressure fuel pump unit on all electronical control engines have been included in an enhanced maintenance schedule. This schedule ensures regular inspection, cleaning, and calibration of the fuel pump unit to maintain their optimal performance and reliability. Next is condition monitoring. After enhanced maintenance schedule, the next one is condition monitoring. We have implemented a condition monitoring program for the high pressure fuel pump unit, utilizing vibration analysis, pressure monitoring, and other relevant diagnostic techniques. This proactive approach allows us to detect every sign of pump degradation or normal behavior. So these are the conditioning monitoring. Next is training and awareness. Our engineering personnel have undergone specialized training to enhance their knowledge and skills in the maintenance or operation of high pressure fuel pump units. So, and you can give in conclusion, the failure of the high pressure fuel pump unit on the electronic control engine was addressed promptly, effectively. The failed unit has been replaced, and preventive measures have been given. So this is just like how you'll be able to communicate to your superintendent in the field. So now the next one is question 6. State with reasons 3 properties required of a cylinder lubricant for a main engine operating on heavy fuel oil. So HFO means heavy fuel oil. B. Describe with the aid of sketches an electronic controlled cylinder lubrication system, stating how the timing and the quantity of cylinder lubricant is regulated and set. So now the answer is, first of all, they say 3 properties required of a cylinder lubricant for a main engine operating on heavy fuel oil. Number 1 is high thermal stability, and number 2, there should be adequate alkalinity. So for heavy fuel oil to work properly, these 3 properties must be in place. Number 1, high thermal stability, right? High temperature in the cylinder liner. There should be high temperature conditioning to prevent the formation of harmful deposits. Next, there should be adequate alkalinity. So now the total base number, that is adequate alkalinity, is also the same as the total base number. So there should be adequate base or adequate alkalinity. And the next one is good detergency and dispersency. Heavy fuel oil often contains impurities such as aspartame and other solid particles. A cylinder lubricant with effective detergency and dispersency properties can keep these impurities in suspension. So when we use good detergency, it keeps these impurities such as aspartame on on a different level, on suspension level. So now the next question is description of an electronically controlled cylinder lubrication system. So the diagram here shows electrically controlled cylinder lubrication system. So the yellow buttons are the cylinder oil, where the oil enters. Then we have the pump station with standby pumps. So when this pump station pumps it, it goes through the lubricator and the lubricator. So we also have the accumulator, right? There's the accumulator here. So now let's explain it now. An electronically controlled cylinder lubrication system regulates the timing and quantity of cylinder lubrication based on engine operating condition. So now the use of an electronically controlled cylinder lubrication system is that at a particular time, an accumulator will be able to use some sensors, right, which will know that at this point lubrication should be poured, right, just like an automated system. So that is the use of an electronically controlled cylinder lubrication system. There should also be an alarm system. When it's very low, there should be an alarm system, and there should be some sensors who will trigger the lubricator to pour at the designated terminals. So we have the lubricant supply and distribution, right? We have the lubricant metering unit. So now this lubricant metering unit always checks, is the lubricant finishing? Let's add more. Then the next one is the timing and quantity control. So the ECU, the central control unit, the sensor signal helps to calculate the optimal timing and quantities of lubricant for each cylinder. So all these are just the electrical aspects. We have the lubricant metering unit, the electronic control unit, right? The timing and quantity control unit. We have the lubricant injection. So this lubricant injection, at the predetermined timing, the metering unit injects the measuring quantity of lubricant into the cylinder lining area. So it pour it into the cylinder lining area. Are we together? This is the cylinder lining area. So when it detects, you now pour it here. So now this is just steps. Then we have the feedback and monitoring system. The feedback and monitoring system just check, as the lubricant reduce, it has not reduced, if it has reduced, it sends the feedback to the monitoring system, which triggers the lubricants to be poured at the different lubricant terminals. So now number 7, with reference to turbochargers, explain how the operating performance of a turbocharger system may be assessed. B, state with reasons defects which adversely affect the operating performance of a turbocharger. So number 1, assessing the operating performance of a turbocharger system. So the first question, they want us to explain the operating performance. What is the performance of an operating turbocharger? They want us to assess it. So now, the operating performance of a turbocharger system can be assessed through various methods. So there are lots of various methods. Number 1, we have the boost pressure measurement. So this boost pressure measurement helps to boost the pressure in a critical parameter that indicates the efficiency and the performance of a turbocharger. Next, we have the exhaust gas temperature. So this one depends when it's very high than normal. This exhaust gas temperature can be used to check the turbo efficiency and performance. Next, we have the visual inspection, using your eyes to check it, right? Next is noise and vibration analysis. When you hear unusual noise or excessive vibration, instead of doing very silent noise, you're hearing that kind of thick vibration, you know that the operating performance is going below a particular level. So performance testing, so these are all under that aspect. So now the next question is, let me come back, state with reason defects which adversely affect the operating performance of a watcher. So they want us to give defects that affect the performance. So number 1, we have worn or damaged bearings. So when the bearings are damaged or worn out, it can affect the performance. 2, we have compressor and turbine wheel damage. So when the wheel damages of the turbine is damaged, it can affect the performance. 3, when there's leaks in the intake or exhaust system, when there is a hole or a crack in the exhaust system, you can hear those kind of performance. There might be a decrease in the performance. 3, we have the wastegate malfunction. The wastegate is responsible for regulating the turbocharged boost pressure. So when there is an issue in the wastegate which helps to increase or boost the performance of the turbocharger, there might be a tendency of a decrease in performance. Next, oil contamination. When people buy faulty oil that is not properly processed, where it can cause this decrease in performance. Next is heat damage. So now the next question is question 8, with reference to 2-stroke slow speed engine pistons, explain what is meant by the term thermal stress and how this can cause cracking of crown surfaces. B, sketch a cross section of a piston, labeling the main components and indicating coolant flow. State a cause of each of the following defects: burning of crown caps, carbon deposition, and cooling system. So now the first question is, we're expected to with reference to 2-stroke slow speed engine piston, explain what is meant by the term thermal stress. So now, thermal stress in 2-stroke or low speed engine pistons and its effect on cracking of crown surface. So now, thermal stress refers to what mechanical stress induced in a material due to what temperature variation. So when the temperature is high, temperature goes low, there might be that kind of thermal stress which may affect or lead to cracking of the crown surface. In the case of pistons, thermal stress can cause cracking of the crown surface, right? When there's high temperature, it goes down, and there is no constant temperature. This may lead to thermal stress. So now these factors include temperature gradient. So now during engine operation, the crown surface of the piston are exposed to high temperature. Next is differential expansion. When the expansion is not linear, it's differential, it goes up and goes down. This may lead to the cracking. Repeated cycles, right? The piston undergoes numerous heating and cooling cycles during engine operation. So these are just factors that causes thermal stress. We have temperature gradient, when the temperature goes up, down. Differential expansion, when the expansion is not linear but just goes up, this can lead to differential expansion. And repeated cycles. And also the material properties. When the material used to create the piston engine is not strong, this might cause cracks of the crown. Next is cross section of a piston with main component and contact flow. So this one, just each of it has a lot of explanation with the main component. So we have the piston crown. The top of the surface of the piston is known as the piston crown. Then we have this piston skirt. The cylindrical portion of the piston that contacts the cylindrical wall is the piston skirt. Then the cooling spaces, there is a gap or cavity, that is called the cooling space. Then the next one is what? The piston rings. So there are rings that between this piston. They provide the seal between the piston and the cylindrical wall. Are we together? That is the piston ring. Then we have the gudgeon pin, a pin that connects the piston to the connecting rod. So these are the components, and you can get them. Next is the coolant flow, right? Arrows indicating the direction of the coolant. Then the next question is causes of the following defects. Burning of the crown upper surface. So there is the burning of the crown upper surface. So what is the cause of this burning? When there's insufficient or incorrect cooling. So when the cooling is not sufficient and is incorrect, it can cause the burning of the crown upper surface of the piston. Indicate cooling such as reduced coolant flow or blockage of the cooling passage. So where air is supposed to pass, there's some blockage. This can cause burning of the crown upper surface. Next is carbon deposit in the cooling spaces. So poor combustion. So when there is poor combustion, there is carbon deposit. This can lead to the defects, which may lead to inefficient combustion, can result in incomplete fuel burn. And when there's incomplete fuel burn, there's incomplete combustion. This can lead to what? Carbon deposit in the cooling spaces. So now the last question is question 9. So now, with reference to an engine air starting system, explain why slow turning system is fitted, and B, state with reason when a slow turning system operates. So now, and C, describe with the aid of a sketch an air starting system, explaining how the slow turning system operates. So now the first question is, we should be able to explain why slow turning system is fitted. So the reason a slow turning system is fitted in an engine air starting system is because a slow turning system is fitted in an engine air starting system to provide a controlled and gradual rotation. So the aim of it is just to ensure that it is fitted to ensure that there is what? Control and gradual rotation of the engine crankshaft. If it is not fitted, the crankshaft will be what? Hitting the surface and the cylinder of the piston. Next, and also it allows the engine to build up sufficient momentum. So it must be fitted for the engine to build up what? Momentum. Next question is, state with reasons when a slow turning system operates. So they're asking us, when does a slow turning system operate in an engine? The slow turning system operates during the initial stages of the engine starting process. So when the engine is starting, there's what is called a slow turning system, operation system. So when it's starting at the initial stage, that's when the slow turning system operates. It is topically engaged when the engine is at rest and needs to overcome the inertia and resistance of the internal component to achieve the required starting speed or torque. So at the beginning, that's where the initial stage is. So when a slow turning system operates in an engine air starting system, is at the initial stage, when it's leaving a state of rest, mount up and gain momentum. That's when it requires the slow turning system at the initial stage. Now the next question is, describe with the aid of a sketch an air starting system, explaining how the slow turning system operates. So description of an air starting system with the aid of a sketch, explaining how the slow turning system operates. So we have an air starting system which typically consists of the air starting torque or the starting motor. We have the air starting motor, we have the control valve, we have the compressed air supply, slow turning system. So now this air starting motor, the motor is driven by compressed air. So when the air is compressed, it is connected to the engine flywheel or starting ring gear, so the air starting motor. So now this air starting motor uses what? Compressed air, and it's also connected to the flywheel. Then we have the control valve. The control valve regulates the flow of all compressed air. So now there's a kind of a cover, like a tube, like a tap valve. So this helps to regulate the flow of compressed air. Next is the word compressed air supply, right? The compressed air supply, as we said, which is used to power the air starting motor. So now this compressed air supply requires for the starting engine, and is usually used to store what? Air. It is stored at high pressure and can be delivered to the air starting motor on demand. So this compressed air supply is just like name say a balloon. The air, compressed air is there. So when there is high demand for the air starting motor to be what? Opened, and that compressed air will now be used to power the air starting motor, which will be what? On. So now we have the slow turning system, like the previous question. We say the slow turning system is used to help in what? Initial stage. So now the next, so during the starting process, the control valve is adjusted to restrict the flow of compressed air to the air starting motor, right? This slower rotation allows the engine in internal component to gradually overcome their inertia and the resistance. So this is the use of the what? The slow turning system. Are we together? Now the slow turning system ensures a safe and controlled starting process. So that is all about the question. So the question is, describe with the aid of sketch an air starting system. Explain how slow turning system operates. So you can be able to give them the air starting motor, which needs the compressed air to power it on. Then we have the control valve, which helps to control and regulate the pressure. We have the compressed air supply, just like a balloon, which stores the pressure, that when you need it, you ignite it and power the starting motor. We have the slow turning system. This slow turning system helps to create that initial stage for the air starting motor to begin. And that is the end of March engineering knowledge motto for March 2015. Thank you.